So I run this company called Mystifly. We are a platform company which connects airlines on the supply side and various travel sellers like Bookings and Expedias and Costco's and Amexes of the world. My background, if I were to divide into three parts, I started my career with a couple of big firms, Google, worked on Gmail, worked with Adobe on streaming servers. We were one of the first teams to build streaming servers on HTTP. Did few years with InfoEdge, the parent company of Naukri. So that was the first half. Second half has majorly been startups and entrepreneur. Mystify is my third company as a founder. I've had one failed startup, which was into renting space. I've had an exit. We sold a company to Flipkart. I've been a part of Flipkart as well. And prior to this was with a couple of fintechs in India and abroad. So today, what I want to speak about probably is a known thing about CTOs and engineering leaders, but the keynote or the key thing which I want people to take away from this could be around premature optimization, right? So very often what I've seen, especially in the startup scene, is that a lot of engineers want to do sexy work. I don't know if I'm allowed to use that word, but I think a lot of CTOs or a lot of engineering leaders, our major challenge is around convincing engineers to solve customer problems and not really get into solving interesting problems or solving problems by using latest tech stack. So how do you solve for tech debt? Continue to create tech debt while simultaneously driving innovation. So the agenda is I'll talk about 3 stages of the companies. Various companies are into 3 stages: ideation, growing, scaling, and what is architecture that you and your teams should kind of cater to within these stages. We will talk about, my personal agenda has always been that I know microservices has been a very, very big buzzword, but avoid fancy architectures if it's not needed. So we'll talk a little bit about that. So one key away or one key thing which again from this 20-30 minutes conversation, if I want all of you to take away is probably the single line that no single architecture fits all scales and domains. This is a known thing, but I think in engineering, a lot is about repetition. You have to repeat the obvious thing time and again, and that is how it works. So I was talking about 3 stages of the companies. There is a starting stage, there is scaling stage, and then there is after you've hit a certain scale, you want to optimize. This is where we currently are as Mystify. We serve hundreds of millions of requests on a daily basis. Now for us, scale is not a problem, but optimizing scale is. Scaling things at a certain or at a lower cost is a problem, which a lot of companies come across. So designs again vary according to company levels and scale. This is something which is very, very important. Right, so we start with ideation phase. We're talking about companies where, let's say, the team size is probably less than 10. Whatever metrics you choose, it could be in terms of performance or platform metrics, which is query per second, throughput per second, or it could be number of users, 1,000 users, 10,000 users, 100,000 users. So till you are 100, I think in that range, you are pretty much in ideation stage. I think one of the challenge which I faced in almost all companies in that 0 to 1 journey is telling the team that you have to focus on solving the customer needs. Sometimes you don't have to write code to solve the problem. One of the companies which I did, Watson End, we had our website on Shopify for a very long period. We were running all of our operations on Excel, so there was hardly any technology involved in running the operations, in running the company itself. So at times at times people do over engineer things, and There's a very famous quote by Martin Fowler, which says that, if you're not regretting the architectural decisions that you've made in 2 years, then you've definitely, over-optimized. So you have to really solve for probably today and maybe, a few months down the line, maybe a year or two, not beyond that. So focus on solving the company-specific issues. And this I'm saying, from an engineering point of view, like I did not attend or could not attend the last, session, but in the last we're talking about, few of those things, context to engineers. So giving this context, I think, has really helped in every company that I've worked, giving these kind of context to engineers, that, right, understanding the customers without, let's say, even writing a single code, if that is possible, that is something which needs to be done. Faster iteration is the key, right? Prototyping becomes very, very key, rather than making a perfect product or, perfect platform, probably ship it out. Daily deployments, weekly deployments become very, very prominent, or, becomes a very successful thing, rather than just waiting on it, sitting and building something, staying in stealth for months. This is something which has worked, I think, in India, and if I talk to friends in Valley, right, same thing. The whole, again, I'll quote someone else. There is this guy, David Sachs, who was CPO of PayPal. I mean, his quote was around this, that the superpower of startup is the number of iterations they are able to do. I generally compare startups to large companies in a sense that a startup is like a bike in Bangalore traffic. A large company is like a truck. The truck wants to move fast. It has the whole intent, but the traffic will not let you move. Bangalore startups, especially, if you're not massive, you'll find your way. So you have to, be like a bike, especially when you're in ideation phase. Software, as I said, right, isn't always the answer. There are a lot of companies, even larger ones, teams, specific teams in those companies, which do not solve everything by writing code, right? Excel is a great tool. There's always, build versus buy possible. So there are a lot of tools which are possible. This is, when we talk about ideation phase. So when do you, what should be your architectural strategy? One thing we've talked about is understand the customer, solve their problem, probably try not to over-engineer, keep it minimum. Like we all talk about minimum viable product, but in ideation stage, that minimum viable architecture is very important, which could mean, no architecture at all, right? Which means that it could be zero coding. And with the advent of low-code platforms, I think this has become very easy as well. So yeah, adopt a just enough approach for near-term customer needs, because you are finding, or any company in this stage is finding a product market fit. Shipping becomes very, very important. Learning from those deployments, customer feedbacks become important. Technology infrastructure, don't go for fancy tech. Most of the startups in this, or most of the companies in this phase, probably should start with easier languages, concentrate on, engineers which are easily gettable. You don't have to go for JVM-based languages. Python probably works pretty well. This probably is a must, which is, start with a monolithic architecture. In last few years, probably I would have interviewed thousands of engineers, and a good portion of them, do talk about microservices as their either achievement or some form of expertise, and they've not seen a certain scale. So there I strongly recommend that stick to monolithic till you hurt, and we'll come to that, where you start thinking away from monoliths, right? One of the examples that I give to my team and consistently across the, I think, ecosystem as well is, if you can't manage a large mansion, I compare it to a monolith, which has few, let's say, maybe 100 rooms, which can be compared to modules. If you can't do that, if your team cannot do that, it's very difficult to maintain even a small village, which means a lot of houses which need to communicate to each other. There are too many independent, actors, workers in that ecosystem. So if you can't do first, right, second probably is not going to be easy. It is going to be 10x difficult. So at least at the ideation stage, monolithic architecture works pretty well. You don't have to worry about latencies. You don't have to worry about common libraries, shared libraries, right? You don't have to worry about performance a lot. You can, a very small team can deploy things. A very small team can ship things. Vertical scaling is very much possible. And then again, third-party services, core competencies, unless you're building, your core, probably, prefer buying the solutions. And in last couple of years, there's a lot of solutions, which have happened. I see a lot of companies, even in this conference, which are building dev tools. So, the advent of dev tools also has been a blessing. So this is majorly about ideation stage. Then we talk about scaling stage. See, a lot of companies would fall in starting or ideation phase. Right, the scale, of course, could vary, but right, when you talk about scaling, we're talking about, from that 0 to 1 journey to now 1 to 10 and 10 to 100. So we're talking about probably tens of millions of users, hundreds of millions of queries per day, requests per day. So when you start hitting that kind of scale, again, your definition of MVA is no longer what it used to be in ideation phase, and that's super important. So we have had those kind of challenges, in probably, last 3 companies that I've been a part of, and these are some of the things that we come across, and where we start saying that now we need to think of re-architecturing, there's a need of re-architecturing, and there's also a notion among, I think, especially among teams in India, engineering teams in India, which is re-architecture, pardon me, so not engineering teams alone, but organizations in totality, which is they see re-architecture or the need for re-architecture as a failure, which is, why you could not predict it in, why this is in, you couldn't see this in the past, right? I mean, of course, hindsight, you can go, in hindsight, everything is possible. But, from what I've learned, it's actually a success, because when you're not thinking of those scales, when you're not thinking, when you're concentrating on product market fit, you don't have to engineer things. It delays your product shipping. It delays, the core, problem that any company is solving, which is the customer need, right? So unless you've identified that, probably, stay away from kind of scaling. The key point which I want to share is that if there is a need for re-architecture, because of scale, it's a success. Right? It's a success for the organization, it's a success for engineering teams. There is no way you could have predicted it, right? And even if you are predicting a certain scale and you overcome that, right, you pass that, it's again a success, right? Because the company is doing better than what you thought it would. So some of the reasons where we started thinking of scaling, of looking at things in a different manner, things did not work, was majorly around as you scale. Like for us, in last 4 or 5 years, our code base size is like pretty huge. It's 13 million plus lines of code. We have around 80 to 90 engineers of various caliber and skill. And for us, slower time to market, and we also deal in enterprise companies. So for both on supply side and demand side, large airlines have their own tech systems. Demand side definitely are tech companies. We're talking about Expedias and Bookings of the world. So for us, shipping fast becomes very important. We have to be better than our customers in a certain sense. Our teams need to be better, faster. Monolith, after a certain period, or any I mean, I'll not confine this to a monolith, but a lot of those architectural decisions or decisions or let's say execution does fail, right? So one of this or the important pieces, which is can you ship faster? Now with, let's say, in our case, uh, can we ship faster with 13 million lines of code, probably 1,000 plus tables and uh, 700 plus modules and whatnot, right? There's a lot of overlapping. How you build again, monolith is there are common libraries, there are common shared services. Who will own the source of truth? That becomes very, very difficult. So slower time to market. There are a lot of companies, at least in our aviation industry, which ships probably once in 3 months, once one release a quarter. Because otherwise, in enterprise setups, reliability is a key factor. Your system always needs to be available. Your system needs to be highly reliable, right? So it's not possible to ship fast, which is where you start thinking of, re-architecture. You start with a small team, but then, it grows to various smaller teams or, a lot of teams. Can they collaborate with each other all the time? It's just not possible. What happens to onboarding new engineers? It becomes very, very difficult to dive into larger code bases. And let's not even talk about documentation. I've not seen any company with good documentation. And I worked in Google and Adobe and Flipkart and whatnot. Scaling challenges, yes. If you're a mono rep, monolith, of course, you will hit a point where, right, you cannot grow beyond a certain size of the node or the cluster, etc. I mean, not cluster, but node. Deployment dynamics. I think this is something which we still struggle with. How do you deploy certain features? How do you migrate? Again, the re-architectured task together. Does it fail? Do you have to roll back? And it actually happens much more than what we want or what we anticipate. Complexities, yes. So these are probably some of the key factors where again your need for MVA really, really changes, which is now are you shipping slower? Are you failing too far? I mean, are you failing much more often when you ship? Is QA, becoming a hindrance, right? Because what happens is, if this is not well segregated, you're probably in first iteration, you're solving, of your testing 100 test cases. Now you build or ship 2 more features, which has again 20 test cases. If you have not automated all of this, and yes, you should not automate initially. Now, the next iteration actually consists of testing 120 test cases, and this only grows, right? It becomes iteratively slower. So, your QA itself becomes a bottleneck. What could be your goals? I think from problems that we have stated in the past slide is where the goals come from. Stay ahead of rapid business expansion. Of course, because all of us work in a certain industry, right? You have to delight the customer, but you also have to, be ahead of the competitor, and especially if you're into SaaS, especially if you're into enterprise. I mean, probably enterprise or SME, it doesn't matter. Reliability becomes important. Scaling teams to match growth becomes important. You have to hire a certain level of engineers. You have to hire engineers, right, in a certain tech stack. Language migrations, right? So you go, you start looking into languages which are much more reliable, which were probably not very verbose, but right, handle concurrency, handle asynchronity, handle various third-party systems. So you might have started with probably a language like Python, but then you move to Go, JVM, Java-based languages, Groovy, Scala, Java, or C#. Performance becomes a key bottleneck. It's very, it's almost impossible, right? Not completely impossible. One of the products that I worked initially was Gmail, and Gmail is monolith, right? So they are doing great work, but of course, not everybody is blessed with Google engineers. So enhancing performance becomes really a key factor. So you can, of course, throw a lot of hardware, but then, then someday you'll hit a, roadblock that, again, your revenue is actually lesser than your infra cost, right? So performance enhancement becomes like a key factor. Operational efficiency, we talked about this, DevOps is process automation, scaling, all of these things that we have covered. So I think these probably, form major goals around this. So the need for, again, MBA in a scaling stage revolves around this, right? You have to be fair to your business counterparts, but you also have to, because you're bringing probably much better quality of engineers, you also have to, be fair to them, give them interesting work. Yeah. I'm sure, a lot of you have done enough research, have, spent enough time in execution. But as I was saying that, if you can't handle a large mansion, it is very difficult to, starting from a small village, it's difficult to maintain that. Right, so what happens is microservices, yes, there is a segregation. You can scale independent units, there's a possibility, for example, in e-commerce system, if your search to buy ratio is very high, right? So you're getting probably, a billion searches, but you're selling only 1,000, probably 100,000, you're doing only 100,000 orders. So which means your search and discovery system needs to be much more scaled than your order management, right? So scaling independent becomes very important and easier. Deployment, though again I've put it as a pros, but somehow, right, there's a catch to it, because you are, unless this is fairly sorted, which is how different services will talk to each other, right, deployment might be independent, but it might not really be, that easy to achieve. I mean, there's a whole journey to it. Technology stack, I feel, is probably one of the key things which helps. Like we still have been, from last 10 years, we have been majorly on C#, and C# is like not a very, loved language, at least in India. That is what we have seen, but, people prefer Go and, Java and whatnot. I mean, you kind of get rid of dependence on one particular language stack or tech stack. Security boundaries is definitely easy. It's, because you understand systems, smaller pieces, much better than larger ones. Cons, I feel, that there are a lot, right? Because there are multiple independent entities. So getting that cooperation, how they deal with each other, how they talk to each other, even debugging becomes very difficult. One of the things then what happens is, earlier you would probably dealing with, in-process latencies, which is probably tens of milliseconds, sometimes just in milliseconds. Now now that exchange or the communication is happening over network, which now from tens of milliseconds can go to, 100 milliseconds, probably even in a second, especially when you're a SaaS company, right? Because you're you're interacting with different systems. Deployment, as we talked about, deployment, monitoring, debugging becomes very easy. You have to figure out, this causation and correlation becomes, setting that up again becomes difficult. So how do you do this? I think there are certain material which I can definitely recommend. It's there on internet. I've kind of put this up in a slide, but again, this is easier said than done. In a lot of interviews that we take, and right, one of the major questions around this is, how would you find bounded context? How would you segregate the boundaries, right? And a lot of people do falter in it, right? Because it's not only about taking a business boundary. One, the business boundaries are never clear in a system. Then there are multiple owners of that source of truth, right? So segregation of that data becomes very difficult. Automation of testing, again, if you are a large code base, is very difficult. Um, Getting your engineers, getting your developers to write, tests becomes important. And in ideation phase, if you have QAs, they're, I'm assuming they're majorly, manual QAs, right? So you hire people who can do automation. They need to get the context, right, where onboarding becomes like super important. Uh, People who know the system can code, which is your engineers who are scaling it, getting them to, again, as similar to documentation, getting them to write automation tests also is probably a lot of hard work and a lot of repetition. Giving them the context, why is it important? Uh, so what has worked for us is keep the, like what we have done internally is we have kept these two things very different, which is the re-architecture pieces, the migrations, with the feature development, right? So when we deploy and roll out features is again on a different date than when we do migrations, when we split the services. So that has worked fairly well for us. Go slow. Again, you can't achieve, if you've taken, let's say, the step of changing your architecture after a certain scale, I'm sure, there's a certain size of the code base. There are, there is certain reliability that your system needs. And this will not be solved in a few months. I mean, that's, it will not, I mean, your team, if it says that, or if you're saying it to your organizations or CEOs, what happens majorly is that you're over-promising. In 99% of the cases, of course, there'll always be exceptions. But again, use an incremental migration approach, right? Do it slowly, test it out thoroughly, and probably have a horizon of year or two. That works fairly well for a lot of companies. So how many of you actually been, have done this journey of, changing the architecture, re-architecturing your, code bases or your system or your platform, and you've also done, let's say, the thought process was moving from a monolith to SOA or, microservices. And how many of you have actually, run this? I mean, can we zoom this? But this is like, we have segregated business boundaries, but then the, the database or the storage system is pretty much same, right? So different systems are talking to the same data points, and I think a lot of companies do get stuck here, which is a certain table or a certain data point, is owned by multiple people or multiple entities in this case. I'm also correlating entities to the teams, right? I mean, a team will handle probably a few of services. So the different entities, different services are talking to the same data points, which causes a lot of issues. So again, so because a lot of companies do get stuck here, and there is, and this is one phase which takes a lot of time. I think what has worked, again for us and for a lot of other companies is, right, while you're making that transition, like, which service X or Y will be the ultimate owner for the source of truth, intermediate have a service which is just probably doing the CRUD operations, right? So rather than X or Y owning that data piece, probably have a very small service Z, which is now owning, and X and Y talking to Z, rather than directly hitting it. In that approach, I mean, probably figuring out the use cases, and then based on that, segregating is much more easier, much more successful, as well. Repetition, I think it's majorly about whatever has been done. Like, we talked about incremental migration. Whatever succeeds, just keep on doing it, right? I mean, boring does work. You don't have to experiment at each stage. What happens when you've achieved a certain scale? I mean, this is what we're talking about, the third stage, which is optimizing. You have hit a certain scale. right? But now your infra is costing you a lot, right? So your customers are happy, uh, but your finance team is not, right? So this is probably again a very sub 1% of teams hit this, which is, what do you do then? Uh, what we have observed, what I have also observed is there is this path to the number of teams that operate in these, various areas. You start with small teams. When you're scaling, you have, a lot of small teams or large teams, and then, it does come down, right? Because you're probably not really spending a lot of time in feature development. Or if you are, maybe feature development is something that you've made easier, right? So rather than 5 people working on this now, probably you need only 2, right? So this definitely comes down, and if this is happening again in your org, which is if intentionally you're bringing down the, team size because you're able to ship faster, you're able to ship reliably, right? I think it's a huge, success. Just pat yourself on the back if you've reached here, right? But the aim is to reach here. Uh, you also start doing some kind of, again, it might happen for some companies or some organizations or some systems. It might not happen, which is a lot of these services also start getting merged. You figure out that, this probably will not hit a certain scale, right? Or this particular independent service will not require 100 node cluster. So maybe why not, club it with something else? We've already talked about, horizon. So optimizations actually is much larger than, time frame wise, much larger than, this scaling as well. I'll give you an example. So if I take my company's example, so what we do, because we're connecting travel sellers and airlines, right? What is the scale that we're talking about? So let's say any of you being a user wants to travel from Bangalore to New York, and you go to 4 travel sellers. Let's say you go to ClearTrip, you go to an Agoda, you go to a GoMMT, you go to Paytm, and you do a search. Some of these being our clients hit our system, and because each of them is a different business, right? Their business logic would be different. So ingress for us probably would be 4 and 5. Now what happens is there are X number of airlines which operate Bangalore to New York, which is if they're flying directly. Then there are one stop. So I could also then travel to London. I can go to Singapore. I can go to Dubai. I can go to Australia as well, right? So some of the stopovers. So if there's one stopover, then the permutation combination increases. If there are 2 stops, again the more number of combinations. So what happens is we start with 5 incoming requests, but our system, right, hits around probably 20 to 50 different systems, airlines and other aggregators, etc. Now all of these systems are all they are all tech companies. They have different point of failures. They have different response times, right? And each of these airline will probably on a certain day will operate probably 10 flights, 20 flights, right? And if we include stopovers, then there are a lot of other combinations. So what happens is on an average, we get around 200 to 1,000 itineraries, for that request, per request. So we're talking about 5 into 1,000 to it can go as high as 10,000. So 5,000 itineraries is what we kind of get back, and then we use our own logics and we do filter, we process, we do revenue management. So we run around 50 filters. Now 5,000 to 50,000 into 50, right? So this is the number of messages that is being processed for one search. So we're dealing with hundreds of different systems. We're dealing also this response, all this processing, and dealing with or integration with system needs to happen within a couple of seconds. Now, what is the challenge that we face, right? With the advent of e-commerce, I think the consumer has become, I think more, if I could use that word, unreasonable, because the experience they demand is similar to e-commerce, but here we're dealing with third-party systems. So you have to make your system reliable. as you kind of give them more and more options. So right now, let's say travel is very price centric, but one of the features, which let's say as a traveler I would want is that I don't need food, but I definitely want priority, onboarding. My bag needs to be right, need to be there fast. So I need to save time. But is there any offer from the airline or from online travel company which can be that I'm not paying for the food, but I'm paying for my time saved? It just does not exist, right? So as you bring, or the ecosystem brings those kind of features, the payload itself, does increase. So for us, right, you're giving more value, but the time in which you need to finish this, right? You need to calculate, process, return, send it back to the end traveler, remains same. So how do you optimize, right? You're processing lot more messages, but how do you, do you rewrite the libraries? How do you just continue to optimize, the response times, the latencies? How do you keep on caching? And we're talking about live inventory, right? So for a lot of these companies, optimizing beyond scale, is very important, because the other option for us then becomes is, right, we could shift away from multi-tenant models. I can have probably a cluster per client, but yeah, then my CFO will probably, throw me away. This probably is, very, very important. You need very senior engineers to do this. Again, you move away from the need of MVA itself, right? It is no longer minimum. And again, have a longer horizon for this. This does take time. This cannot also be summed in, or it cannot be covered in, sprints, right? You can't probably achieve a significant improvement in 14-day cycles or 30-day cycles or 1-week cycles. So this we have talked about architectural phases. When you start, probably there is, rapid iteration becomes very, very important. You want to ship faster. There is a single team, maybe 4 people, 5 people, 10 people. As you're scaling, because you're building feature, you're also spending a lot of time into, process efficiency. You're also kind of setting up things. You do require many teams. Velocity, scalability, continues to be really important. But as you start optimizing, your system platform is set, but again, you want to incur lower cost. And then, right, from platform metric point of view, or even from business, right, that the platform being sustainable, the platform being reliable, is the most important or the key factor, rather than talking about that, oh, I want to ship faster, right? So probably shipping 2 new features is not going to have an incremental impact on revenue, but if your P99 comes down or your P95 comes down, it could have a major negative role. How do you? This is probably one of the key thing that you can look at, that if you are still increasing the team size, and I'm not even talking about the whole tech team. I'm talking about companies or the teams which probably are responsible for scaling part of it. It could be a platform team, but again, the number of people, the number of teams, the skill level, it kind of keeps on changing. This is one way to look at it. If you still need to scale more, or if you're at the optimizing stage. With that, I end this. This is probably some of the key points that I would love you guys to take away, which is, always start from this, that no single architecture works for every company, and especially whatever. A lot of larger companies do discuss their architectural decisions to platform, how they're building very openly, but what works for a 50,000 company doesn't work for a 50 people company and 500 people company, right? So you have to understand the framework, but then applying it on your own problem set, is the key. And last point, probably, code writing is a means, not always a solution. I know we're sitting in a DevCon, we're all engineers. this is what we love to do, writing code, but this is not something the best solution, at least for the customer or at least for your, business stakeholders. So yeah. So that's it, from my end. Anything that I can answer.
Thank you for the wonderful presentation. And any questions?
In one of your slide, you mentioned the scaling to optimizing, right? So that time you mentioned from monolithic to microservices, then to consolidating the architecture. Can you give an example for microservice to consolidating architecture?
So basically, see, this will vary from team to team, or company to company as well. What we have done is initially when we were in phase, or when we were in that migration phase, we had split our payments and invoicing, but that's not the core of what we do, right? It's a very again, we are comparable to a e-commerce company, right, where the search to order ratio is very, very high, right? So which means I really need to scale search. I need to have a lot of segregation in my search and discovery, but I don't need a lot of segregation in my backend offices modules, right? So we ended up doing, consolidation there. What happens if, or what would have happened if, we wouldn't have done it? I think it's just a higher cost, because it's not the key area, right? There's not a lot of feature development on those back office modules. Rather than having 10 people, right? If you're consolidated, you can work with 3 people, 3 engineers.
So because microservice is for just better manageability, right?
Yeah.
Then from there to optimizing means how it works. Right?
No, so for optimizing, again, because we are also then talking about fewer teams, right? You want to, reduce the teams. You want to not have people and, in different teams or on a different modules or services, and you don't want them to be there and not do significant work, right? So there you also end up, consolidating things.
The architecture you are talking about.
It is. I mean, see, consolidation is also an optimization.
Okay. So consulting people and teams is one.
Yes.
And anything else other than that in the optimizing?
No, so again, it's not always people-centric. See, if the business requirement would have been that, right, I need 10 people on those back office modules, for an ERP company, this will not happen, right? But because, again, our, the kind of company that we are, again, we are very focused on search and discovery and order management, and not so much on invoicing, right? Not so much on payments. It's somewhat very stagnant or very slow in deployment. But for an ERP company, probably, the tail end of the whole transaction would be more convenient, would be more, feature driven. But for us, that was not the case. So it's more business driven rather than, let's say, people driven.